Hello everyone. In the previous video, we discussed about the electric field, electric forces, and electric field intensity. So we are now in a position to think about the work energy transfer with respect to electric forces. So for that, we are defining the electric potential difference. So before going towards electric potential difference, we need to understand about the electric potential and electric potential energy. So basically, what is electric potential? So basically, electric potential shows the strength of electric field lines at a specific point. Suppose we have a plate of positive charges and the electric field lines are leaving the surface of this electric charge plate. So as we know that the electric field intensity at this point is greater than compared to this point, let's say point 1 and point 2. Electric field intensity at point 1 is greater than the electric field intensity at point 2. So basically, electric field intensity is a vector quantity represented by E, which shows both strength and direction. But electric potential shows only the strength of electric field line at a specific point. So we can say that the electric potential at point 1 is greater than electric potential at point 2. So conventionally, we can define the electric potential by, let's consider a positive test charge which is placed at a reference point which is at a distance of infinity, which means that the effect of this electric field on this point, reference point, is zero. So if we want to move this positive test charge from the reference point to inside an electric field, let's say point 1, then some work has been done. This work done per unit charge is basically called the electric potential. So we can define an electric potential as, so the work done required to bring a unit positive charge from infinity to a point in an electric field against the electric field intensity is called electric potential at that point. So this electric potential is represented by V, and which is equal to the work done per unit positive test charge from bringing it from infinity to point A inside an electric field. And electric potential is a big scalar quantity which shows only the strength of the electric field lines at a specific point. It is a scalar quantity. So one of the important points about the reference point is that we can choose this reference point anywhere outside this electric field. We can choose here, we can choose it here. There is no effect on this positive test charge to bring it to the point A. And the unit of electric potential is joule per coulomb. Joule per coulomb. So we are now in a position to define electric potential energy. So what is electric potential energy? Electric potential energy is basically the work done in moving this positive test charge against the electric field from point A, let's say from point A to point B. Then this work done is stored in the form of energy, and this energy is called electric potential energy. So we can now define the electric potential energy by the work done moving charge from one point to another point against the electric field intensity is stored in the form of electric potential energy. So if we move this electric charge from point A to point B, some work is done, and this work is stored in the form of electric potential energy. So we represent this work done from point A to point B by energy, which is represented by U from A to B, which is equal to force dot displacement. So after the definition of electric potential energy, we can write down the electric potential as V equals to, instead of work done, we can write down the energy required to bring this positive unit charge from infinity to point A, from infinity to point A is equals to the energy at point M divided by Q naught minus energy at point infinity divided by Q naught. So we know that the electric potential energy at this point is equals to 0. So we can write down the electric potential as UA divided by Q naught. So we are now in a position to define electric potential difference. So as the name suggested, the difference in potential is called the electric potential. So now to understand the electric potential difference, let's consider the two plate of charges, one having a positive plate and the other one having a negative charges. And the electric field lines are leaving the surface of positive charges and entering to the negative surface of an electric plate. So if we have a positive test charge placed near the negative plate of charges, and if we want to move this charge against this electric field towards point B, then the electric potential at point A is less than the electric potential at point B, because as we move this point towards point B, then the electric potential of this charge increases. So the difference between this point potential at point A and point B is usually called the electric potential difference between point A and point B. So now we are in a position to define the electric potential difference. So we can say that the electric potential difference is the work done per unit positive charge in moving a charge between 2 points in the field. So the difference in potential is equal to the work done moving the charge from point A towards point B. And this work is stored in the form of electric potential energy, which is U from A to B. And this del sign represents the difference, which we can say that the difference in potential at point B and at point A, equals to the electric potential energy from point A to point B per unit charge, which is equals to U potential energy at point B and potential energy at point A. The other name of electric potential difference is voltage. And the unit of electric potential difference is the same as electric potential, which is joule per coulomb. The another unit of electric potential difference or voltage is also volt. In the honor of Alexandra Volta, we name for the unit of voltage or potential difference is volt. Now to understand the electric potential difference or voltage, let's consider the example in which what is the electric potential difference between 2 points in an electric field if it takes 600 joule of energy to move a charge of 2 coulomb between these 2 points. So if we have 2 points A and B, point A and point B, and we have 2 coulomb of charge located at point A, and the energy consumed by this charged particle to move it from point A towards point B is 600 joule. So the potential difference between these 2 points is equals to the energy which is consumed from point A to point B divided by the test charge. So the energy is given, which is 600 joule, and the charge is equals to 2 coulomb. So the resulting potential difference between these 2 points is 300 joule per coulomb, or we can say that 300 volts. So it's all for today's lecture. See you in the next one.